Hello and welcome to episode 16 of How to Code Games in BBC Basic. In this video we're going to be looking at conditional display and some very simple coordinate-based mathematics to simplify the overall production of graphics on screen. Okay, so you'll remember, I think back in episode 13, we were looking at the proc display invaders procedure, and at the time we kind of skipped over what was happening in the call to proc invader and proc blank. And I did mention at the time that we'd be revisiting those, and I think it's about time that we did. So as you'll recall, the overall purpose of display invaders is to essentially populate the aliens on screen so that when you start the game, all of the aliens are displayed in their original positions, and then this procedure gets called multiple times later on in the game to essentially refresh the screen. So if you've shot an alien, it won't be there anymore. If the aliens have moved from left to right, it basically redraws the grid of aliens just under every second, I think. So that's what the procedure does overall, but the actual way in which it does that is rather clever. Now, if you weren't using a programming language or making use of the facility of things like loops and variables, what you could do is write lines and lines and lines of code that essentially just have a series of print statements that just run in sequence with short delays between them. So you could print something on the screen, and then you could have a delay of less than a second or so, and then print a blank over the top and print it somewhere else on the screen. So that would be a very, very rudimentary way of displaying graphics on a screen. But obviously that's not a very efficient way of doing it. Not only is it going to take a lot of time to write all of the code, but it's really just not very efficient. What you can do instead is make use of variables, a very small amount of mathematics, and the various variables that store those values, and just iterate through them. So what I'm going to do is pull up a diagram to try and explain what the code is attempting to do first of all. So you will recall that we've looked at this grid here before, which represents the space percentage array. And the array is essentially a way of capturing true or false values to indicate whether or not there is an alien in a particular position within the overall grid. But actually this array is not a true representation of the screen, because actually each of the aliens occupies multiple pixels or sixels on the screen. So this diagram below here is actually the representation of what's going on with the screen memory that's displaying the aliens at any given point in time. So this is what the grid looks like on screen when it's first displayed at the very beginning of the game. You'll know that the X percentage variable is set to 10 and the Y percentage variable is set to 2, at least on level 1, because those are the starting positions of those variable values. And that also indicates the top left corner of the first alien in the grid that will be drawn on the screen. And essentially what has to happen next is each column is drawn in sequence, and there are procedures and a little bit of maths that help to basically tell the program where to draw each alien in sequence so that they all appear in the right place, and then subsequently as they move from left to right they get redrawn with blanks over the top of them to hide the alien that was in the position previously. So that's essentially what the code is attempting to do. One thing I will just highlight is that the aliens themselves within a column are actually stacked on top of each other, which is slightly confusing because when you see them first displayed on the screen, it does appear as if there are blank gaps underneath each alien and they're not quite sort of crammed on top of each other. But the reason for that is that we're using sixels. So you can see here I've run a short program to illustrate that lines 2, 3, and 4, which you can see here, lines 2, 3, 4 on the screen, they actually occupy these sixels that make up the overall graphic. But you can see that by the time we get to the fourth, essentially line 4, which is the third line of sixels that will make up the overall alien, you can see that actually the sixels involved are very slight. They're actually just these two little dots here and here with basically blank space in the bottom two of the three that make up the overall sixel. So it's just basically, if you were to imagine that as one sixel, it's only the top left corner of that sixel that's been populated with a little dot, and that gives you this kind of effect of a blank space. But actually, if I was to replace the sixels making up this alien with fully filled in blocks, you would actually see a long column of cyan here without any gaps between it. However, we do need to have gaps in between the aliens to the right of each one. So there are these gaps here, and those are genuine screen gaps. So I'm just calling that out now because when we do look at the code, it might appear as if we're not allowing space between the aliens horizontally, but actually in practice, the way that the sixels work, we don't actually have to. So that's what the code is attempting to create, and the way that it's doing that is with a set of variables which we just need to quickly unpick. So we already mentioned the x percentage and the y percentage variables here, which are controlling the starting position of the overall grid itself. But then on top of that, we've also got something called J and K percentage, and these are actually used to control where the aliens are drawn either horizontally in the case of the J percentage variable or vertically in the case of the K percentage variable. And as I said before, there's a very small amount of maths that's used to make sure that you can draw each alien at the right starting position. You'll recall from the way that these sixel graphics are created, you only actually have to specify the top left corner of each of the sprites that you're going to draw, and the use of sixels along with the down and back control characters means that the rest of it is essentially done for you. So you only have to set the print tab cursor at the top left each time, and the rest of the alien will get drawn using those control characters, which also control the positioning of each individual sixel that makes up the overall graphic. So if we dive back into the code, what you'll see here is, we'll ignore proc key test because that'll be the subject of another video. But the first thing that we're doing is we're setting the value of this J percentage. So the J percentage is the one that controls, as I was saying before, controls which column of aliens we're going to draw. So we're starting with the first column, obviously when the program first executes this procedure. So J, even if we untangle all of this maths that's going on here, it evaluates to 0 because I percentage was already set to 0 up here. And if you try to take away, and O percentage is also 0, so 0 minus 0 is 0, and if you multiply 0 by anything, you still get 0. So that was a long-winded way of saying that J percentage is 0. Then from there, we move on to the next line where we create a loop within a loop. So bear in mind that we're already inside a loop here. This is a repeat until loop. And then the next sort of sub loop, if you like, is controlling the actual population of the columns. So the repeat loop is drawing everything, if you like, from left to right. But then within each step within that repeat loop, we have a further for loop that does everything from top to bottom. Within a single column of aliens. So here we've got K, we're basically looping from a value of 0 to 4, which you'll recall, that's because those are the starting values of the Q and the R percentage variable of the overall, that controls the positioning of the overall space percentage array. So you can read this as I'm going to loop from 0 to 4, so because basic index is from 0, that means we're going to run this loop 5 times, which is what we want, 1, 2, 3, 4, 5 of the aliens that we're going to draw. So basically this just says we're going to run this 5 times, and within each iteration, so each time we run this for loop, what we're going to do first is check whether or not the position within the space percentage array is true or false. And obviously at the start of the game, all of these values are going to be true. So we're going to draw an alien every single time. And then it says, okay, well, if that is true, so you could write this as if equals true, but in BASIC you don't have to. So if and then a value, that just assumes you're asking, is this true or false? And in this case, is it true? If it is true, then we're going to call this proc invader procedure. So proc invader, what it's actually doing here is it's setting the position of the print cursor. So you notice that it doesn't actually print anything. If you look at this statement, all it does is it sets the position of the print tab, And then this is very important. It puts a semicolon at the end. As we know from the last video, that semicolon can be pretty significant. What that means is I want you to set my print tab cursor to this position on the screen, and then the next print statement that is issued should start from that position. That's what the semicolon is doing. Now it's only valid for until you call the next print command. Obviously anything that comes after that print command, unless that print command itself had a semicolon on it, is going to start from the obviously the next line down. But anyway, all this is doing is it's setting the position of the print tab, and you can see here that all that we're doing, mathematically speaking, is we're taking the x and the y percentage variables, which are the x and the y here, and at the beginning x equals 10 plus 0, so still 10, and y is 2 plus k, which is 0 times 3, and 0 times 3 obviously is still 0. So at the first position, we're just saying at a position, I want to set my print cursor x across, so 10 positions across and 2 positions down, which is what we've illustrated in yellow here. So that is the starting position. So I set my, my print tab cursor there. And then the next thing that I need to do is I need to determine, well, what am I actually going to draw in that position? And in this program, it uses something called on GOTO, which is a quite clever use of the GOTO command. Now, GOTO gets a bit of a bad press in BBC Basic and indeed most programming languages that support GOTO commands. The reason for that is because they can become quite difficult to follow in the code. Also, they are dependent on you hard coding particular line values, which can get you into all sorts of trouble. In general, people tend to recommend that you rewrite GOTO statements using procs. But this facility of on GOTO is actually quite a clever way of keeping the code relatively tidy and efficient. So I've got a little program here, which I'm going to just load up because it's quite a nice way of demonstrating it. So this program takes a value of 1, 2, or 3, and depending on which one I press, so let's go with 2, it tells me I've pressed 2. And if I run it again, I would select 3, it says you press 3, press 1, you press 1, and so on. So it doesn't really matter what sequence I put these in. I could say 1, 1, etc. Now you might think, well, that's a bit of a pointless program. It's just repeating what you've written. But actually, if we look at the code, it's using this on GOTO syntax. So what it's saying is take the value from the user, which is just a single a percentage value here, and it's saying, okay, well, depending on what the value of a percentage is, I want you to go to line 40 or 50 or 60, and that is indexed from 1. So if I give a value of 1, so a percentage equals 1, it says, okay, go to line 40. But if I give a value of 3, it goes, oh, okay, so I need to go 1, 2, 3, so go to line 60. And that's what this code here is doing. So it's taking the value of k percentage, adding 1 to it, because obviously k percentage is 0, or can be a value of 0. So we actually want to index it from 1 rather than index it from 0, because if we were to try and go to on 0 GOTO, that wouldn't work, because GOTO requires a value of 1 or higher. So here, if we go back to our grid here, the value of k is 0 at the start. So if we add 1, that means we're going to go to line 2670. And line 2670 prints the alien 2 sprite in the position that the print tab has been set to. Now, if we loop through on the second attempt, k percentage will now be 1. We'll be setting our print tab to this position now, because obviously, although x remains the same throughout all of these print commands, y, or technically the value of y is still 2, but the overall value that we're giving to the print tab command is now a value of 5, because it's 2 plus the k percentage now being 1. 1 times 3 is 3, so add 3 to 2 and you get 5. And that's the position here. And that's what would happen on each subsequent iteration until we get to the bottom where k percentage equals 4, which is the last of the iterations because we're looping from q to r, so from 0 to 4. Now we're also further using that k percentage here to pick which of the GOTO commands to go to. So each time we run this or call this procedure, the value of k will have incremented by 1, and so the GOTO statement increments by 1. So it's just a very tidy and efficient way of conditionally displaying different types of aliens depending on where in the column you've actually reached within the loop of the program. So yeah, it's quite a nice way of using the goto command. Now you'll notice each one of these print statements obviously has to go to line 2710 to finish the procedure, because obviously if we didn't have this on here, it would print this and then it would try printing this and then printing this, which would defeat the object of the on goto. So that's why we've got this extra line to make sure we finish the procedure. And of course, when you finish the procedure, it will go back to the procedure that called it. This will loop around a second time or a third time or a fourth time, and we'll be calling proc invader again, except that this time around, obviously the value of k will be +1. And so what proc invader actually does will change, because the positioning of the print cursor will have moved down the screen, and also potentially the type of alien that we print will need to change as well. So it's a very clever way of basically structuring the way in which you display the graphics on the screen. And it's just a handful of lines of code, a very simple bit of coordinate maths, and what you end up with is a nice bit of conditional display with the on goto as well, and it gives you a really nice result. So that's what we're going to finish off with in this video. It was to say, this was just a way of explaining the mysteries of proc invader and what this nested for loop is up to. We don't really need to cover too much about proc blank, other than to say that proc blank itself is really just putting a blank instead of an alien in the position in the grid. So that comes into play later in the game when you're trying to actually shift the positioning of the aliens, or when you've shot an alien. Obviously you don't want to then reprint the alien in position. But this procedure makes use of the J percentage variable instead, because what it's interested in knowing is where on the screen exactly does that blank need to go. If it's because the aliens are shifting from to the left or to the right, then actually what it needs to do is print the blank across where the alien used to be. Or if it's to hide an alien that you've shot, obviously it needs to print it over the top of where an alien used to be. But we'll probably look at the exact details of how that works in a future video. For the time being, we're going to satisfy ourselves with the nice bit of coordinate mathematics here for proc invader. Yes, that's probably it for this episode. So hope that all made sense to you. Hope that it was of some level of enjoyment for you, and that you'll join me for the next episode in the series. And until then, goodbye.